So let us discuss what is a system. System is defined as connection of components or interconnection of subsystem which operating on the input signal produces desired output. Here this is a system. It is an interconnection of components or interconnection of a subsystem which operating on the input signal produces desired output. If input and output are continuous time signal, then the system is said to be continuous system. If input and output are discrete time signal, then the respective system is said to be discrete system. Now, mathematically, the system is represented as, the system operator is denoted by T off. T off is called as a system operator. Means this system operator operating on the input signal produces desired output. So this can be represented mathematically as T off is called as a system operator. T off is called as a system operator. That system operator operating on the input signal produces desired output. In case of continuous system, system operating on the input signal x of t produces desired output y of t. In case of discrete system, system operator operating on the input signal x of n produces desired output y of n. So remember, T off is called as a system operator. Next we will discuss about properties of system. It is also called as classification of a system. So go one by one properties. First property, a linear and non-linear system. So let us assume system operator operating on the input signal x1 of t, then it will produces desired output y1 of t. And system operator operating on the input signal x2 of t produces desired output y2 of t. Then the system operator operating on the input signal, where input signal is sum of two or more input signal with their weightages a and b. Here I taken only two signals. Sum of two signals I taken here whose weightages are a and b. If the system operator operating on the input signal, where input signals are summed with their weightages, then the system produces the output as a into y1 of t plus b into y2 of t. Then the system is said to be linear. See here, then the system is said to be linear if system operator operating on the input signal, where input signal is a into x1 of t plus b into x2 of t, then the system produces the output a into y1 of t plus b into y2 of t, then the system is said to be linear. Otherwise the system is said to be non-linear. This is a continuous system. In case of discrete system, same procedure. If system operator operating on the input signal x1 of n produces a desired y1 of n, and system operator operating on the input signal x2 of n then produces desired output y2 of n, then the system is said to be linear if that system operator, this system is said to be linear if this system operator operating on the input signal, where input signal is sum of two or more input signal with their weightages a and b, then the system produces desired output as a into y1 of n plus b into y2 of n. Then the system is said to be linear. Otherwise the system is called as non-linear. So alternatively I can define a system is said to be linear if that system satisfies the principle of superposition theorem. If a system is said to be a linear if that system satisfies the principle of superposition theorem. Otherwise the system is non-linear. Go for second property, time invariant and time variant. If system operator operating on the input signal x of t produces the output y of t, then the system is said to be a time invariant. This system is said to be a time invariant if this system operator operating on the input signal, where input is shifted t0 unit to the right side, then same shift at the output, then the system is said to be time invariant. Just I want to say, any shift taking place at the input, same shift taking place at the output by the system, that system is called as a time invariant. Suppose I have input x of t minus t naught, then output is y of t minus t naught. How many unit is shifted? T naught unit. Output is also shifted t naught unit. What side it is shifted? Right side. It is also, output is also shifted right side. Suppose I have x of t plus t naught, then output is y of t plus t naught if the system is said to be time invariant. If this condition is not satisfied, then the system is not time invariant, or it is also called as a time variant. If system operator operating on the input signal x of t minus t naught. So here what is the nature of input signal? Shifting of the x of t. Same shift will be taking place at the output. Similarly, in case of discrete system, if system operator operating on the input signal x of n produces output y of n. System is said to be time invariant if system operator operating on the input signal, here input signal is shifted version of x of n by amount n naught unit, same shift will be taking place at the output y of n minus n naught. Then the system is said to be time invariant. Otherwise, the system is called as not time invariant or time variant. I written here, a system is said to be a time invariant if a time shift of the output signal causes a corresponding time shift in the output signal. A system is said to be time invariant if a time shift of the input signal causes corresponding time shift in the output signal. Otherwise, the system is said to be not time invariant or time variant. Go for third property, memoryless. It is also called as a static, and memory is also called as a dynamic. A system is said to be a memoryless if the output at any instant of time, depends on the input at the same instant of time. Again I will explain. The system is said to be a memoryless if the current output depends on current input. The current output depends on current input. Nothing but if the output at any instant of time depends on the input at the same instant of time. If the above condition is not satisfied, then the system is said to be memory. Example, I have written here, y of n equals to x of n into g of n. Here output at n equals to n depends on the input x of n at n equals to n, and the system is memoryless. If the present value of output depends on present value of the input, here also n, here also n, therefore it is an memoryless. In case of a continuous system, y of t equals to x of t into g of t. See a second example, y of n equals to x of n minus n. Here the current output at n equals to n depends on the input at n equals to n minus 1. Hence, the present output does not depend on the present input. Therefore, the system is said to be memory. Similarly, in case of continuous, y of t equals to x of t minus 1. So, next property, casual and non-casual property. A system is said to be a casual if the present value of the output, nothing but current value of the output, the present value of the output does not depends on future value of the input, which means the present value of the output can be depend on present value of the input and or past value of the input. Overall, the present value of the output does not depends on future value of the input. If this condition is satisfied, the system is said to be non-casual. Example, y of n equals to x of n into g of n. Here the current value of the output depends only on the present input. It does not depends on the future input. If the current output does not depends on the future input, the system is said to be casual. Take next example. Y of n equals to x of n minus 1. Here the current value of the output depends on present value of the input or past value of the input. Here the current value of the output does not depends on future value of the input. Example I will give. Take n equals to 2, positive value of n equals to 2. What is the present value of n? N is 2. So here y of 2 equals to 2 minus 1 is 1, x of 1. So input is at n equals to 1, but output is at n equals to 2. Means output depends on past value of the input. take n equals to minus 2. Y of minus 2. What is the present value of the output? At n equals to minus 2. What about your input? What about input? X of minus 2 minus 1. X of minus 3. Our input is at n equals to minus 3, but output is at n equals to minus 2. Once again, the output is depending upon past value of the input. Therefore, the system is CAS 1. Similarly, go for third example. Y of n equal to x of minus n. Take n equals to 2. Present value of the output at n equals to 2. Where is the input? X of minus 2. Minus 2 is a past input. Again, the present value of the output depending on past value of the input. Take another n. N equals to minus 2. Output will be at n equals to minus 2. Where is the input? N equals to minus 2. Minus into minus plus 2. X of 2. Nothing but input is at n equals to 2. But output is at n equals to minus 2. So this indicates output is depending on future value of the input. Hence the system is non-causal. So next property. Bounded input, bounded output stable or unstable. A system is said to be bounded. A system is said to be stable. A system is said to be bounded input, bounded output stable if and only if every bounded input results into a bounded output. A system is said to be bounded input, bounded output if and only if every bounded input results in a bounded output. See here, in continuous system, for bounded input I represented as a bx. Bounded means its value is readable. Bx value is less than infinite. What is input? Is a magnitude of x of t. So bx value is greater than or equal to magnitude of x of t less than infinite. If input is a bounded input, if I applying for the system, then the system is a stable if the system produces a bounded output. What is a bounded output? By. Output is also less than infinite, but by value should be greater than or equal to magnitude of y of t. If this condition is satisfied for any given system, then the system is said to be a stable or bounded input, bounded output stable system. Otherwise, the system is said to be unstable. Here B stands for bounded, X stands for input, B stands for a bounded, Y stands for an output. Similar in case of a discrete system, if we have a bounded input is applied for the system. What do you mean by bounded input applied for the system? Means Bx is less than infinite, greater than or equals to magnitude of x of n. If this input, if I applied for the system, then the system produces a bounded output. What is a bounded output? By. Its value, system output, bounded output is a by. Its value is a less than infinite, greater than or equal to magnitude of y of n. Then the system is said to be stable system. Example, y of n equal to x of n minus 2. Now, if x of n is a bounded, input is a bounded, bx, its value is less than infinite, greater than or equals to magnitude of x of n. Then what is the magnitude of y of n? Taking magnitude on both sides, magnitude of y of n, by is less than infinite, greater than or equals to magnitude of 1. Because I am taking magnitude of y of n on both sides, x of n is a bounded means x of n minus 2. It is a shifted of the input signal. It is also bounded. Only signal is shifted with respect to time. Amplitude never changes. Magnitude means only this amplitude. X of n is a bounded input. This x of n we can shift to the right or left, but its amplitude never changes. Therefore, x of n minus 2, its amplitude never changes, but x of n is a bounded. After shifting also, x of n minus 2 is also bounded, means y of n is also bounded, and the system is said to be stable system. Similarly, I explained this example in case of continuous system. So last one more property, invertible and non-invertible system. A system is said to be invertible if the input to that system can be recovered. The input to that system can be recovered from the system output. See here, we have here one of the system, I call it as a system 1. Input to this system is this one. If I am recovering this input using its output, so how to recover this input using its output? I have to connect one more system in series with the system 1. Using this system, if I am recovering this input signal here, then the system 2 is called as inverse system and system 1 is called as a invertible system. A system is said to be invertible. A system is said to be invertible means I have to take two systems, system 1 and system 2, connected in series. This is a input, this is output, and output of the system 1 acting as input for the system 2, and system 2 output is same as input of the system 1. If this condition is satisfied, then the system 1 is called as invertible, system 2 is called as a inverse system. Example I given clearly. Say y of t equals to 10 into x of t. Here I have a system 1. What is the input is x of t. What is the output of this system 1 is given 10 into x of t. Can you guess what is the system it is? It is a multiplier. It is a multiplier by 10. Hence input is x of t. This system multiplied by 10, output is 10 into x of t. I have to identify whether the system is invertible or not. I have to design the second system. I have to design this system 2 in such a way that it has to produce output as same as input x of t. Hence I am designing this system again as a multiplier by a value of 1 by 10. Hence this value is multiplied by this input. What is the input for system 2 is 10 into x of t multiplied with 1 by 10. 10 get cancelled, x of t. And system 2 gives input, original input of the system 1. Hence this system is called as invertible, this system is called as an inverse system. Same example I given in another example, go for in discrete. Y of n equals to x square of n I given. What's the input? This is x of n. What is the output I to get? X square of n. Definitely it is a square. Whatever input will given, it will be output will be square of the input, hence x square of n. So now what I have to find out here? What's the system 2 I have to design such a way that I have to recover the original signal x of n. Hence I decided it is a square root. So here input is x square of n, the system 2 is a square root, it gives the output is plus or minus x of n. Square root of x square of n is plus or minus x of n. Okay, let us take example here. Suppose x of n is a 2, what is a x square of n? X square of n, it is a 4. What is the w of n? Square root of 4 is 2. Suppose x of n is a minus 2 here. What is x square of n? Again 4. What is the square root of that value is? Again 2. But here input is plus 2 I given. After recurring from the system 2 I have a 2. 2 is same. I record original signal. What about the next input value? If x of n I given minus 2, but I not record minus 2. I record 2. It is wrong. Hence this system is not invertible. Therefore inverse system does not exist. So it indicates that if I am giving the different input, we should not get the same output. Means if for the different input, if I have a same output, then the system is not invertible. Inverse system does not exist. Suppose for the different input, if I have a different output, then the system is said to be invertible, then inverse system is exist. So overall I want to define invertible and inverse system in alternatively a system said to be invertible if distinct inputs, different inputs gives distinct outputs, different outputs, then the system is said to be invertible. For a different input I have to get different outputs, then the system is invertible. Otherwise for different input I am getting the same output, then the system is not invertible. For different input plus 2 and minus 2 I am getting the same output and the system is not invertible. Thank you one and all.